Okay, today we talked about, well, in the past couple of chapters, we've talked about linear equations. And what a linear equation is, obviously, something that looks like this, 3x plus 2y, let's say, equals 6. Something that looks like that. And this is an algebraic equation that basically models what looks like a line on a graph. Okay, we've worked a lot with that. We've worked with how to get this into slope-intercept form, those types of things. So slope, if you remember correctly, slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. And once I get those two pieces of information, I can actually graph this line. So the difference is I've got the equation that looks like this, and I want to make it look like this. And again, this is all review if you followed along so far. So I subtract 3x from both sides. I get 2y equals minus 3x plus 6. Divide by 2, divide by 2. Got to divide everything. So I'm left with y equals negative 3/2 x plus 3. So if I was to graph that equation right there, I would say that the y-intercept is 3, so I would put a dot on 3, and I would use my slope, understanding that slope is rise over run, to get to the next dot. Therefore, I could graph the line at that point. So quick review there. Now, we've got, in the book, this is the example they gave in the book, 2y equals 8. We basically have two equations that they're looking at, x plus 2y equals negative 8. And they're saying, what is the solution to this problem? And they give you two equations. This is not done any differently. We still need to graph these, and the first way of solving the equation is to actually graph these lines. And if you're a little bit ahead of me, you would know that the reason we're graphing these lines is that so that we can figure out where they intersect, which was what the solution would be. So these are called systems of linear equations. And that's what I'm about to do. I'm going to do this problem right here. So we take these two examples, and I'm actually going to color code. One is going to be red and the other is going to be blue. So I'm going to take negative 3x plus 2y equals 8 as 1. That'll be in red. And here's the other one, x plus 2y equals negative 8. Just copied from the previous slide. So in order to, I'm going to graph both of these lines. So in order to graph both of these lines, it'd be nice if I had them both in slope-intercept form. I could go through, since they're in standard form right here, I could go through and find the x and y intercepts. That might help me, but in this particular case, I look very quickly at this example, and I notice that one of the intercepts is going to be a fraction, so I don't want to do that. So let's go through slope-intercept form. Well, how do I switch this red equation, equation number 1, into slope-intercept? We'll throw a 2 up here too as well. So I got to get the y alone is what I'm looking to do. So I'm going to add 3x to both sides. I cannot combine 8 and 3x, so what do I have left with? 2y equals 3x plus 8. And then I'm going to divide by 2. Divide everything by 2. And that's going to give me y. Here's my first equation. Y equals 3/2, 3 over 2, x. I'll leave it just like a fraction because slope is fine when it's in a fraction form. It actually helps me to follow the rise over run principle when it's kept in a fraction form. Plus 4, 3/2 x plus 4. So there's one equation that I've got. Switch colors here, and I'll do the same. I'm going to subtract x. So I have 2y equals minus x, because I can't combine these, minus 8. That's an x, by the way. Let me erase that. Clearly define the x. I'm going to pick up my pen. Negative x minus 8. I divide everything by divide everything by 2. And I have y equals negative 1/2 x minus 4. So there are my two equations in slope-intercept form. Let's see what they look like from a graphing perspective. Let me get graph. And we'll go grab a graph. So there's my graph. Let me make it a little bit bigger here. Push it over, rewrite my equations that I'm graphing. So my red equation was y equals 3 over 2x plus 4. And my blue equation was y equals negative 1/2 x. And these are just copied from my, my previous slide. So let's graph the red one. So I got plus 4, so I'm going to put a dot on 4. There's my dot on 4. And my slope says up 3 over 2. So I could go up 3, 1, 2, 3. You see, hopefully you see those little red dots, over 2. And there's my next point. And I'm going to put a couple more points on this. Just change the thickness of my pen here so I can get a full. There, much better. I'm going to put a couple more points on this line by using the slope. So if I can go up 3 over 2, I can also go down 3, 1, 2, 3. If I go to the left 2, which ends up being technically negative 3 over negative 2, isn't that the same as 3 over 2? Right? So the equivalent fractions. So if I go down 3 to the left 2, I can put another point. And let's go down 1, 2, 3 over 1, 2. I'll put another point, and I'll put one more 2. 1, 2, 3, 1, 2. And I got my graph of my line right there. Boom. Boom. There's my line. So let me switch pen colors. Now we're going to look at this equation right here. I've got a y-intercept of negative 4, so I start there. There's my y-intercept of negative 4. And I look at my slope here, and I've got negative 1 over 2. So I could go down 1 over 2, put a point. Let's go up the same way I did the same thing. If I go down 1 over 2 is the same as going up 1 over 2, and I'll put a point. Up 1 over 2, and I'll put a point. And I got a good enough line there, so I'm going to draw the line through it. There's my line. Sorry, I wish I could put a straight edge on an iPad, but I can't do that. So I look at my graph and I say, okay, here's 2 separate lines. Where do these things intersect? And I notice this one kind of laid out for me right there. That's where they both intersect at the point of negative 4, negative 2. So in essence, what does that mean? Well, what that basically means is, let me pop a new slide here. This is my solution. That's my answer, negative 4, negative 2. I found that by graphing and figuring out where they intersected at that point. I'm going to go back to my original problems. I've got my answer of negative 4, negative 2. I'll throw that up over here. And I've got, let's go back to my original, before I change them over to slope-intercept form. And let's plug in those points for each of these equations. So negative 4 is my x, negative 2 is my y. If I plug those in, I got negative 3 times negative 4 plus 2 times, I move the y, negative 2 equals 8. If this is an actual solution, this should be a true sentence right here. Negative 3 times negative 4 is 12. 2 times negative 2 is negative 4. Does 12 minus 4 equal 8? And the answer is yes. So let me try that. So I did that one. That one works. Let's try the other one. So now I'm going to plug in the variables here. So I have negative 4 plus 2 times my y is negative 2. This should hopefully give me negative 8 if this is actually true. So I have negative 4 plus 2 times negative 2 is negative 4. And I look and I say, wait a minute, negative 4 plus negative 4 is negative 8. So that's a true statement. That's a true statement. So this is the actual solution to the equation of the lines.